Hello. In this video, we will be doing Newton's second law of motion. In the previous videos, we did Newton's first law of motion as well as some applications. Now we're going to look at Newton's second law. So Newton's second law states, when a net force is exerted on an object, it causes the object to accelerate. The acceleration is directly proportional to the force and inversely proportional to the mass. Now, Newton's second law of motion comes with an equation. This is the equation that it comes with. Let's choose a color. Pink. So this here is the equation it comes with. So we have F net is equal to MA. Now, the first thing I want you to realize that it's not any force that we are putting here. It's specifically the net force. And as earlier defined, we said that the net force is the sum. Okay, and once again, this sign is the sum of forces on the same plane. So here we have F being force measured in newtons, M mass, which is measured in kilograms, and A, which is acceleration measured in meters per second squared. If this is not in the correct unit, you have to check that it is in the correct unit and convert if necessary. Sometimes they give you, say, the unit as kilometers per hour. That is not the correct unit, and you would have to convert it to one of these units. Okay. So what we have is two relationships defined in Newton's second law. The first one being that F is directly proportional to the force. So here the acceleration is directly proportional to the force. Okay, so that relationship here is a direct relationship. That means as one factor increases, so does the other. And if you decrease one factor, the other one does decrease too. This is represented by a straight line where low values of F is associated with low values of A, and high values of F are associated with high values of A. So this is a directly proportional relationship that they define. The second one is that acceleration is inversely proportional to the mass. So here we have acceleration is inversely proportional to the mass. Now, what does an inversely proportional relationship means is if you increase the one factor, the other one decreases, and if you decrease the factor, the other one increases. Here we've written it that A is directly proportional to the inverse of the mass. How would this look on a graph? It would look like a hyperbola. Sorry, let's draw a nicer one. It would look like a hyperbola, where high values of M are associated with low values of A, and low values of M are associated with high values of A. So what's also important to realize is not only the equation, but the relationships that the equation holds for. Well, that is all on the introduction of Newton's second law. So once again, we have that F net is equal to M times A, and that is the equation that defines two relationships, that F is directly proportional to your acceleration and your acceleration is inversely proportional to mass. So that is Newton's second law. Thank you so much for watching the introduction on Newton's second law. Look up for the next videos that will have some examples that we will apply this. Please subscribe, like, and comment on the sections that you would like to see in these videos. Thank you so much.